Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here we are once again going to solve this integral, and here we are given this problem that is integral from 2 to 5 log of greatest integer of x minus 1 over 2 plus 3 is equal to log of alpha times beta square, right? And alpha and beta belongs to the set of natural numbers, and here we have to find the value of alpha and beta, right? So viewers, what we will do here, we'll try to solve this integral, and we'll find the value of this integral, and then we'll compare the result with this expression, and by method of comparison we can find out alpha and beta, right? So let us start. Now here let us assume that this integral is equal to I, right? So we have integral from 2 to 5 and log of greatest integer of x minus 1 over 2 plus 3, and this is dx, right? So now here we'll make use of the method of substitution, and we'll take say t is equal to x minus 1 over 2, right? So t is equal to x minus 1 over 2, so 2t is equal to x minus 1, and x is equal to 2t plus 1, right? So this is the relation between x and t. So here we are changing the variable x to t, right? So now dx over dt is equal to 2, because the derivative of t is 1 and the derivative of 1 is 0, being a constant function, right? So here we have dx over dt is equal to 2, so dx can be written as 2 dt, right? Okay, now here we see that the limits of integration are from t is equal to 2 to t is equal to 5, right? So now what we will do, we'll change the limits accordingly. So here when t is here we'll have x, and when x is equal to 2, we have t is equal to, this is 2 minus 1 over 2, that is half, right? And when x is equal to 5, we have t is equal to 5 minus 1 over 2, that is 4 over 2, and it is equal to 2, right? So now here we see that we have taken t is equal to x minus 1 over 2, and we got dx is equal to 2 dt, and here we have changed the limits. When x is equal to 2, t is equal to half, and when x is equal to 5, then t is equal to 2, right? So now this integral I can be now written as, in terms of t, as integral from half to 2, and we have a log of here for greatest integer of x minus 1 over 2. So for x minus 1 over 2 we can write t. So here we have greatest integer of t plus 3, and for dx we can write 2 dt, right? So now we can take this 2 outside the integral. So we have 2 times half to 2, and we have log of greatest integer of t plus 3, right? And here we have dt. Now here what we will do, we'll try to find out the value of greatest integer of t in a given interval, right? And to find the interval, let us see the limits of integration. So here we have half, and here we have 2, right? And between half and 2 we have the integer 1, right? And here we can take 0 also, right? So this is half and this is 1, this is 2, and the limits of integration are from half to 2, and between half and 2 we have this integer 1, right? So what we will do, we'll break this integral as a sum of two integrals. The first one is from half to 1 and the second one is from 1 to 2, right? So now we can write 2, this is the 2, and here we have the two integrals I1 and I2. So now we can write I1 from half to 1. So we have here half, here we have 1, and we have a log of greatest integer of t plus 3 dt plus we have I2 from 1 to 2, right? From 1 to 2, and we have log of greatest integer of t plus 3, right? Okay, so now we have these two integrals to evaluate, and let us take the first integral. So here we see that t varies from half to 1, right? So when t lies between half and 1, right, that is half and 1, then the value of this greatest integer of t is equal to 0, right? So this is due to the definition of greatest integer function, right? So we can also verify this by taking a particular value of t. So when t lies between half and 1, the value of greatest integer t is equal to 0, right? And here t varies from 1 to 2, right? So t lies between 1 and 2. So the value of greatest integer of t when t lies between 1 and 2 is equal to 1, right? So here for this greatest integer of t we can write 0, and here for greatest integer of t we can write 1, right? So now this integral I can now be written as 2 times, and we have half to 1, and we have a log of 0 plus 3 dt, and this integral I2 is 1 to 2, and we have log of, here we have 1, so we have 1 plus 3 and dt, right? So now we can simplify this expression. So integral I is now 2 here, and we have integral half to 1, and this is log of 3, so we can take log of 3 outside the integral. Here we have dt, and here we have a log of 3 plus 1 4, we can take log of 4 outside, and we have 1 to 2, and here we have dt, right? So now we have very simple integrals. So this is 2, and we have log of 3, and here the integral of dt is simply t, so we have t, and limits are from half to 1. Here we have log of 4, and here we have t, integral of dt t, and limits are from 1 to 2, right? So now we can simply substitute the limits, and we have log of 3, here we have 1 minus half, this is log 4, and here we have 2 minus 1, right? So now I can further be written as 2, and here 1 minus half is half, so we can write it as half log 3, and here 2 minus 1 is 1, so we have simply a log of 4, right? And now we can multiply these two terms by 2, so here 2 and 2 get cancelled, so we have log of 3, and this is 2 log 4, right? And now this can also be written as by making use of the properties of logarithms. So we have log 3 plus log of 4 square, right? And now here we have written this expression, because we know that log of m raised to n is equal to n log m, right? And these two terms can be combined, so we can write log 3 times 4 square, right? Because log of m plus log of n is equal to log of m times n, right? So now we have a log of 3 times 4 square, and now if we compare it with this result, that is a log of 3 times here we'll have b alpha, here we'll have alpha times beta square. So we can compare, so we get alpha is equal to 3 and beta is equal to 4, right? So 3 and 4 are obviously natural numbers, so the value of alpha is 3 and beta is 4, right? And now if we solve this expression, we get I is equal to log of this is 16 times 3, 48, right? So viewers, the value of this integral is equal to log of 48, and the values of alpha and beta as per this problem is given by alpha is equal to 3 and beta is equal to 4, right? So viewers, this is how we solve this important conceptual problem involving greatest integer function.